Yesterday we talked about factoring quadratics when our a value is 1, and that was very easy because we just had to look at that c and b value and find two numbers that added up to our b but multiplied to c. When a isn't 1, there are two methods that we can use. One of them is called guess and check, and guess and check is one that it can take a long time because there could be a lot of numbers you have to guess, a lot of possibilities you have to guess, and that can be time consuming. But there's also times where it could be very quick, and we'll talk about that. So here we have 3x squared plus 8x plus 4, and if we want to guess, factor this by guess and check, we know that the first two numbers have to multiply to 3x squared. Because when we FOIL, the first two numbers give us an x squared. We then know that the last two numbers must multiply to 4. So we could have a 2 and 2, we could have a 4 and a 1, and we could have a 1 and a 4. Because of how we FOIL, if I put 4 and 1 there, that will give us a different result than if I do 1 and 4 like that and swap them. So there's actually three possibilities. There are three different numbers that could go there. Well, then you say, well, what about the signs, the positive or negative sign? And that would be something else we would have to account for. Say, okay, are both of these positive? Is one positive and one's negative? But we just talked about how it matters what number goes there, so that would be different if I did that. So to make guess and check work, you really have to think and say, okay, what could go in these spots and what could the signs be? We have a positive 4 right there. Well, we have a positive 4 and a positive b value. Well, the only way to get a positive number when we multiply is if both numbers are negative or if both numbers are positive. So these two signs have to be either both negative or both positive. And since we have to have a positive b value, these both need to be plus. Okay, so then we can guess any numbers. We can do a 1 and a 3. A 1 and a 4. We'll do that. And then when we FOIL this, we have 3x squared plus 12x plus 1x plus 4. And we can see when we combine these like terms, 12x plus 1x doesn't give us 8x. So we know that can't be the correct answer. So we're going to start all over. Okay, again, we know these two must multiply to that. So we had tried 1 and 4. So we could try 4 and 1, or we can try 2 and 2. Okay, we get 3x squared plus 6x plus 2x plus 4. And that would combine like terms of 3x squared plus 8x plus 4, which is exactly what we got up here. So our factored form is going to be 3x plus 2 parentheses x plus 2. So we only had one wrong guess before we found the correct answer. So this one wasn't too bad with guess and check. However, we're going to talk now about a process that will always work and not just be guessing and checking the whole time. Because if we're looking at this one, 4x squared plus 16x plus 5, if you were to guess and check this, we have 2x, 2x, and then again, we know that these would both be pluses, but then we would have to do factors of 15. Well, we have 3 and 5. We could also have 1 and 15. But we also have to worry about the 4x squared, because we could have x plus 1 and 4x plus 15. So there could be a lot more possibilities that we would have to check here. So this process that we call Xbox, or what I call grouping, the first thing we do is we multiply our A and C. Have to multiply A and C. 4 times 15 is 60. And then we want two numbers that multiply to 60, but add to B, which is 16x. So two numbers that multiply to 60 but add to 16 are 10. 6 plus 10 is 16, and 6 times 10 is 60. So our magic numbers, I call them magic numbers, are 10 and 6. So what we'll do is we rewrite our problem, 4x squared, but instead of writing 16x, we're going to break 16x up into 10x plus 6x and plus 15. If you were to combine these, you would get the 16x from up above. Now, I could have put 6x first and then plus 10x second. It doesn't matter. So we factor out, group the first two terms, and we factor out a GCF of 2x, and we are left with 2x plus 5. And then we look at the second two terms and factor out the GCF there. We can factor out a 3. And we are left with 2x plus 5. If you've done this correctly, then these two things should match. We have 2x plus 5 and 2x plus 5. They match. And then we factor that out as 2x plus 5. We only write it down once. And then our leftovers go in the other parenthesis. And that is our factored form. So you're still having to guess and check your magic numbers up here, but that will be a little bit easier than guessing and checking your full factorization and then having to FOIL it out. So our factored form here was 2x plus 5 and 2x plus 3. So when we do some of these examples down here, we'll talk about some situations where guess and check would be a little bit easier, just because you don't have a lot of possibilities. All right, example letter A, 1A, we have 3 and 8. So two numbers that multiply to 24 but add to negative 10. Okay, well, if it has to add to a negative number, we know we're going to have two negative values to multiply to positive 24. So that is going to be negative 6 and negative 4 equals positive 24. And negative 6 plus negative 4 equals negative 10. So then we're going to rewrite this as 3x squared minus 6x minus 4x plus 8. And again, we could swap these two locations. We're going to get the same answer at the very end. So then GCF here, we can factor out a 3x, and we're left with x minus 2. Now, when you do the GCF of the second two, if your front number is negative, only the front number, if that number is negative, we have to factor out a negative sign as well. So we can factor out a negative 4, and that's going to give us x minus 2. Because remember, yesterday we said if we factor out a negative, the sign changes. If you were to distribute this negative 4 back in, you would get negative 4x plus 8. Okay, this is written down twice, so x minus 2. And then our leftovers, 3x minus 4. And again, you can always double check and FOIL this out to see if it works. All right, letter B. We have 6 times negative 15. That's negative 90. So two numbers that multiply to negative 90 but add to positive 1. Well, if we need two numbers that ever add to like 1 or 2 or something like that, or 3, we know those numbers have to be close together. So if we have to multiply to negative 90, negative 90 is so much larger than positive 1. So I don't want to guess and think about, 45 and 2 or 30 and 3. I'm going to find numbers closer together like negative 9 and positive 10. Negative 9 times positive 10 is negative 90, and negative 9 plus positive 10 is 1. So I'm going to rewrite this as 6x squared minus 9x plus 10x minus 15. Now GCF of the first two, I know that x is negative, but the front term is positive, so I don't have to factor out a negative. So when I factor out a 3x, I have 2x minus 3. And then when I factor out a positive 5, I have 2x minus 3. And again, these match. So 2x minus 3, and then 3x plus 5. Then letter C, our first term is negative, so we want to factor out a negative, but also everything can be divided by 5. So I'm going to factor out a negative 5. That gives me 5m squared minus 12m plus 7. Now, this is a good candidate for guess and check. The reason for that is because there are only, when I write my parentheses, so we're going to write out the negative 5. When I write my parentheses, the only two numbers that multiply to 5 are going to be 1 and 5. So I know one of these has to be 5m, and the other one has to be 1m, or just m. There's no other numbers it could be. I also know that since this is positive and this is negative, that both of these have to have negative signs in it because I have to add to negative 12 but multiply to positive 7. And then the only two factors of 7 are 1 and 7. So I can put 7 here and 1 there. And then when I guess and check, if this is wrong, if this guess and check is wrong, then I know it's got to be 1 and negative 7 there. So if we were to multiply this out, again, leaving the negative 5, we get 5m squared minus 5m minus 7m plus 7. And yeah, this is going to work out to give us our original up here. So that means that this is our correct factorization. And again, if guess and check isn't your style, if you're not comfortable with it, then you can do grouping for all of these problems. All right, on to the next page. This one, 3 times negative 20 is negative 60. So two numbers that multiply to negative 60, but add to positive 7. Well, that's going to be negative 5 and positive 12. So then we're going to rewrite this 3x squared minus 5x plus 12x minus 20. And factor out we can factor out not a 3x, you can factor out only an x. That's all we can factor out of that. And we're left with 3x minus 5. We can only factor out a 4, and then we are left with also 3x minus 5. So then we have 3x minus 5, and then our leftovers, x plus 4. Now this one, 2 times negative 5 is negative 10, so two numbers that multiply to negative 10 but add to negative 9, well, that's going to be negative 10 plus 1 is negative 9, and negative 10 times 1 is negative 10. So 2x squared minus 10x plus 1x minus 5. GCF of the first two is 2x, and we're left with x minus 5. Well, when you get to the second two, you may say, well, what can I factor out of these? They don't have any number in common. If you ever get a situation where you can't factor anything out, you factor out a 1. So we're going to factor out a positive 1, and we're left with x minus 5. So these match, so our factored form is x minus 5, and then 2x plus 1. So we have 5 times 6 is 30. Two numbers that multiply to 30 but add to negative 13. Well, that's going to be negative 10 and negative 3. If you get to the point where you don't need to write these out anymore, you don't have to. If you could just look at this and say, oh, negative 10 and negative 3, and then go right to this step, that is fine. Factor out of 5x, and we're left with x minus 2. And then we're going to factor out a negative 3. And we have to factor out a negative 3 again because the front term is negative in that group. So then it's going to be x minus 2 and 5x minus 3. Now, like we said before, because it is multiplication, the order matters. Like this parenthesis could have gone first, and it means the same thing. All right, so the special factoring patterns, we talked about them yesterday, and they are much more useful when a is not equal to 1. Because when a is 1, again, we could always do the two numbers that multiply to c and add to b, and that's not as difficult to figure out. But when we have a not equaling 1, using these shortcuts is such a time saver. So as a reminder, a squared minus b squared can be factored to a plus b times a minus b. So if we look at 81x squared minus 25, whenever I don't have a b term and I have a subtraction sign, I always check if I take the square root of my first term, my a, that gives me 9x. And then if I take the square root of my last term, if that is also a perfect square, then I know I can do the difference of two squares. So this is going to factor to 9x minus 5 and 9x plus 5. And again, you could FOIL that out to see if you did that correctly. Then the perfect square trinomial will factor to this. So if I have a squared plus 2 times ab plus b squared, it's really simplified to a plus b squared. So again, if I look at an example and I see that my first term, is this a perfect square? Yes, I can take the square root of 49z squared, that'll be 7z. Can I take the square root of my last term? If this is the case, I would say 9 out of 10 times this is a perfect square trinomial. But the last thing that you will want to check is if I take 2, because the formula says 2, times 7z, that the a value, and times the b value, do I get 112z, the middle term? And if you do, then you can rewrite this as 7z plus 8 squared. Now again, you could do it the long way and say, multiply 64 and 49, multiply your a and c, and say what two numbers multiplied to whatever that product is, but add up to 112. So that can get more complicated and more time consuming, so recognizing the shortcut will help you a lot more. The same shortcut applies if we have a subtraction sign, but then it's going to be a minus b squared. So again, I look and see if I take the square root of this, I get 3r. If I take the square root of 121, that gives me 11. And if I do 2 times 3r times 11, does that give me 66r? And it does. So that my factored form is going to be 3r minus 11 squared. All right, so what I want you to do is I want you to pause the video and factor these 7 problems. And then once you're done, unpause it and check your work with my work. All right, so check your answers here. I showed the work for most of them. For the team ones, A and B, A, I didn't really show any work because once you factored out a 3, that became x squared minus 100. What is a difference of 2 squares? Square root of 100 is 10. So that's how I got x minus 10, x plus 10. Make sure you have that 3 in front. Then letter B down there, factored out a 4, and then factored the insides the way we normally do. I do want to talk about the letter D up over there, where once I factored out that negative 1, I got 5m squared minus 6m plus 1. And that one I then guessed and checked because I knew the only 2 ways I could get a number to multiply, 2 numbers multiplied by to be 5 would be having 5 and 1. And then my last term was just a positive 1, and the only way I can get a positive 1 is if I multiply 1 and 1, or negative 1 and negative 1. And because my middle term was negative, it had to both be negative. So there was only one possibility that I could have factored that into, so I did guess and check. And then up here, I did the shortcuts difference in 2 squares and the perfect square trinomials. All right, so if you need to review this, by all means, go ahead and review this, practice some, because this is a skill that is needed throughout the year. So thanks for watching. Make sure to like the video and subscribe.